Welcome to This Explainer. Today, we're tracing a natural language request as it navigates the AI fabric pipeline. Honestly, you can just think of it like a highly secure chronological assembly line. If you've ever wondered exactly how a totally unpredictable user query actually gets safely translated into a complex AI-assisted backend operation, well, you're in exactly the right place. But to really dive into this, we first have to define our boundaries. And here's the thing, AI Fabric isn't meant to just replace your existing application logic. Instead, by really understanding this framework boundary, you'll be able to trace information requests, retrievals, and confirmation-gated actions right down to the exact module responsible for them. We're basically mapping the territory between your domain code and the AI providers. So here's our exact roadmap for today. 1. Entry and application ownership. 2. Security, policy, and context. 3. Intent extraction and resolution. 4. Information and governed actions. 5. The provider invocation matrix. And finally, 6. Finalization and request tracing. We're going to follow your request linearly through these 6 definitive boundaries, just to see exactly how the absolute chaos of natural language is transformed into a clean, sanitized, governed response.
All right, kicking things off with Section 1, Entry and Application Ownership. To begin, we've got to clearly define what happens before AI Fabric even touches a request. The absolute golden rule of this entire lifecycle is that an AI Fabric request doesn't just start in a vacuum. Your Spring Boot application securely owns the HTTP entry and the authentication. Your app is what resolves the user, establishes the tenant scope, and creates the authority-bearing orchestration context that AI Fabric completely relies upon. AI Fabric then receives that context to manage the pipeline. You never, ever let a browser establish trusted identity. The backend creates it, period. Which brings us to Section 2, Security, Policy, and Context. So once that request is securely handed over, it enters a highly structured state machine. Your application first calls the RAG orchestrator, which, by the way, despite the name, coordinates a whole lot more than just RAG. It then delegates to the default orchestration pipeline. This pipeline sorts every available step by ascending order. And as it moves forward, it copies request metadata and policy into an immutable pipeline context. I like to think of it as a snowball, It's just rolling along, safely accumulating processed queries, histories, and intents step by step. Now, what's truly fascinating here is the timeline itself. Before an LLM is even invoked, the system executes these rigorous fail-closed gates. At order 10, boom, we have security analysis. At order 20, access control jumps in to ensure the user is actually allowed in the orchestration resource. We even have optional PII detection at 30 and compliance checks at 40. Ensuring that a denial right here terminates the pipeline safely means we are totally locking down our security boundary before the AI ever gets a single glance at the prompt. Right in the middle of all these checks, specifically at order 22, we hit the orchestration policy resolution step. And make no mistake about this, while a client browser might ask for a specific mode, say requesting to perform a deep retrieval, the server definitively decides if that capability actually exists and if it's permitted. The server owns the allow list. A client signal can never, ever create a server capability that wasn't already configured. Moving right along to Section 3, Intent Extraction and Resolution. Now the pipeline transitions away from those security gates and starts interpreting the actual meaning of the natural language input. But this brings up a pretty massive question, right? How do we actually bridge the gap between a totally unpredictable user query and a secure backend side effect without just letting the AI run wild? I mean, how do we stop an LLM from just executing whatever random code it feels like based on some malicious prompt? Well, the answer is intent extraction, which kicks in at order 50. At this stage, the intent extraction step asks the orchestration LLM to simply interpret the request into a structured intent. It safely isolates the understanding part from the execution part. The framework passes bounded history and allowed action catalogs over to the model and essentially asks it to output a structured intent, like information or action. If the AI hallucinates the format, no problem. The framework progressively repairs it. If it still fails after that, it just safely defaults to an out-of-scope result. It literally never trusts arbitrary provider text as an executable command. Crucially, that extracted intent just describes what the request appears to need. It's only after this intent is extracted that subsequent steps deterministically resolve the working set targets and allowed retrieval spaces. The server-side routing rules validate if those needs can actually be satisfied safely based on policy budgets. Long story short, the model's proposal simply cannot bypass strict server routing rules.
All right, let's get into Section 4, Information and Governed Actions. With the intent securely extracted and validated, the pipeline forks into two very distinct operational branches.
At Order 60, the intent handling step executes the policy-approved branch. It basically routes the context to either the information branch, which handles semantic retrieval and RAG-grounded generation, or the governed action branch. Over in the information branch, it prepares an embedding query directly from the user's request. But in the governed action branch, AI Fabric strictly validates everything against the AI action registry. It ensures the parameters perfectly match the schema before even thinking about invoking your registered local domain services.
And here is where a massive safeguard kicks in. If an action is going to change state, say updating a database, AI Fabric strictly enforces a two-turn confirmation workflow in the backend. Step 1, it hits pause, saves a pending action, and returns a confirmation required state to the user. Notice, no side effect has happened yet. Step 2, on the next request, it interprets the user's yes or no intent. And step 3, only upon a positive confirmation does it actually execute the application handler. This guarantees that UI state alone is never trusted for execution. Pretty smart, right? That brings us to Section 5, the Provider Invocation Matrix. As we map out this complex lifecycle, we really need to clarify precisely when external providers are contacted. This matrix right here dispels a massive myth, the idea that every single step of an AI workflow needs an AI to function. I mean, look at it. For access and compliance, no LLM is needed. That's local application policy. Semantic retrieval? Sure, it uses an embedding model and a vector store, but no LLM generation is needed for that part. Action execution? Purely local Java execution of your Spring domain service. Intent extraction is really the main one requiring an orchestration LLM. It shows exactly which boundaries trigger an LLM, an embedding model, or just your local code. So one single orchestration request might make 0 provider calls, 1 call, or several, depending entirely on the specific boundary. Finally, we reach Section 6, Finalization and Request Tracing. After the branch execution wraps up, the framework prepares to safely hand the result back to your application. In the closing sequence, the pipeline systematically cleans up. At Order 65 and 70, it normalizes the result shape and attaches safe request metadata. But crucially, at Order 90, it sanitizes the response, ensuring absolutely no internal logic leaks back to the client before leaving the pipeline. Then, at Order 95 and 100, it records the conversation and persists the history of the exchange for analytics and context. It does all of this before presenting a clean, provider-neutral result contract back to your Spring Boot endpoint. So, what happens when things inevitably go wrong? Well, because every single stage of this pipeline is explicit, a failed pipeline step instantly tells you exactly which boundary needs your attention. If you see pipeline step failed, access control, you know immediately to check your identity policy, saving you literally hours of prompt engineering guesswork. If it's intent handling, you look at your domain execution or retrieval configuration. The failure names point directly to the exact boundary in the architecture. Ultimately, what you should really take away from this explainer is this exact concept. Read the request lifecycle as a chain of evidence-bearing boundaries. It's not magic, it's architecture. So if you view it this way, let me leave you with this question. Looking at your own systems right now, can you confidently trace the exact boundary where your application's authority ends and the AI begins? With AI Fabric, you absolutely can. Thanks so much for joining me on this deep dive into the request lifecycle.